One here. So continuing on here, stoichiometry. We want to know how many grams of H2 can be formed by the complete reaction of 81.75 grams of lithium with water. We are using the same equation as we just did, so I'll give you the same numbers there. Once again, lithium 6.941, I think. Oxygen 16. And hydrogen 1.008. All right, so follow the same 4 steps that we've been talking about. Balance equation, convert to moles. Mole to mole relationship. And lastly, moles to some other unit if you need to convert. All right, let's take a few minutes here, see what you come up with. Remember, if it's done, don't undo it. Don't go backwards. Okay, let's take a look and see. So again, it is always the same 4 steps. So we're going to start with balancing the equation, which obviously we did in the previous problem. So that is good to go. The next thing that we want to do is convert to moles. Do we need to do that? We do, because again, the only piece of information that's given to us is 81.75 grams of lithium. We will go to the periodic table and we can see that lithium there is 6.941 grams per mole. So that is the second step we're going to do after we balance this guy. We're going to convert to moles. And we'll start with 81.75 grams of lithium. Once again, using the molar mass from the periodic table, grams are going to go on the bottom. Moles are going to go up on top. That is going to cancel. And that'll get us 81.75 divided by 6.941. Going to give us like 11.778 moles of lithium at this point. So that takes care of step number 2. Next step is we're going to go to the equation, and this is really the stoichiometry part of it. We're going to find the 2 things we're interested in. And in this particular case, it's actually the same 2 things as we did previously. We are interested in lithium because, frankly, that was what was given to us. And we were once again interested in H2, which is what we're trying to find in this case. From the balanced equation, the coefficients tell us that for every 2 moles of lithium, we get our 1 mole of H2, which again, in this case, is the only conversion we're really interested in. That gives us our same 2 conversion factors, 2 moles of lithium over 1 mole of H2, or 1 mole of H2 over 2 moles of lithium. Now, in this case, we do want to get rid of lithium. And we do want to end up with H2. So once again, it would be this one here on the right-hand side. Excuse me. That would be needed to do that. So step number 3, I'm just going to actually continue right here. We're going to do that step. That is going to take 2 moles of lithium from the balance equation. Gives us 1 mole of hydrogen from the balance equation. And this is step number 3. And again, that is just the coefficients that are there. I'll put the equals back this way. We were going to basically divide it by 2 in this case, and that will give us 5.8889 moles of H2. Any questions up to there? At this point, we have now completed step number 3. Do I need to do step number 4 here? I do, because I am looking for grams, right? So this is going to require me to use the molar mass. And in this case, I want to use the molar mass of what thing? It is the H2 in this case, because we have converted to H2. So we do again need the molar mass of this guy here. And that would be 2 times 1.008 grams per mole, like a 2.016 grams per mole. Would be our H2 in this case, right? Totally missed that. So the last step here, which is step number 4, we're going to use the molar mass. In this case, we actually want grams up on top so that we end with it. And we want moles on the bottom so that they cancel out correctly. And that means we're going to take our number here basically and times it by 2.016. Going to give us like a 1187 grams of hydrogen. Any questions on that there? You should hopefully be seeing a pattern of, frankly, it is the 4 steps. So step number 1, balance equation, convert to moles, mole to mole relationship, and step number 4 there, go from moles to something else. You could do it all in one step if you want, or one calculation without getting the numbers in between. If you want to get the numbers in between, again, try not to round too much until the very end, and you should be okay. What this really means in real life is if you did this reaction, you tossed in there 81.75 grams of lithium. The reaction went perfect. You weren't a klutz and spilled anything. You should get out of that reaction 11.87 grams of H2 should be the amount of grams of H2 that should be produced in this particular reaction. It is sometimes referred to as the theoretical yield. It's like your maximum amount that you should get out if everything went perfect. Any questions on that one there? All right, let's take a look at another one here. Not that one. Let's take a look at this one. All right, you got 765 grams of C6H12O6 consumed by the body. We want to know what is the mass of CO2. So we want to know how many grams of CO2 here. That's what we're looking for. All right, so some numbers that might be helpful. Carbon 12.01 from the periodic table, hydrogen still 1.008, and oxygen still 16 at this point. All right, take a few minutes there. We're looking for how many grams of CO2 would we produce? I'm not sure if that laughter is good or bad. So let's take a look at this. We want to follow our same steps. That would be a good idea. So first one is obviously we want to make sure it's balanced. I see some coefficients there, so it's probably safe to assume that it's balanced. You should double check, but if you look at it, it will be actually balanced. The next step that we want to do right is take whatever they gave us and convert it to moles. And in this case, we do need to do that as this is what we were given. And it's in units of grams. So obviously, again, to go from grams to moles, we got to go to the periodic table. You do a little addition there of everybody that's involved. So there are 6 carbons, each at 12.01. There are 12 hydrogens, each at 1.008. And there are 6 oxygens. I'll get this. I want to write oxygen, 16 grams per mole. There we go. So again, this is all of our carbons, that's all of our hydrogens, and that is all of our oxygens, just adding up all the parts. Buck 80.2, I think, on that. That's what we're going to get there. So that's 180.2 grams per mole would be our molar mass. And again, we're going to use that as a conversion factor. So we're going to do a 765 grams of C6H12O6. And we're going to put the grams on the bottom here so that they cancel. Moles up on top so that we're left with moles of C6H12O6. Again, the grams here will cancel. If you want to get a number at this point, and I will, I think 765 divided by 1, 80.2. Again, here, I'm not going to round too much on this number because we're going to continue on 4.24528 moles of why can't I write that today? C6H12O6. Any questions on that there? Third step is now to do really the stoichiometry step. It is to go to the equation and we're going to find our mole to mole relationship from the equation. Again, we're looking really at just the 2 things we're interested in. It is this one, which is what they gave us. And in this case, we want to figure out how much CO2. So it really is those 2 guys that we're interested in. And from the balanced equation, we see that for every 1 mole of C6H12O6 we toss in there, we will get 6 moles of CO2 out. That again can be used for our 2 conversion factors. And again, if you want to write them, you can. Here, if you look something like this. Or, of course, you could flip it around and do it the opposite way as well. So you could do it either way. Just go up here, 6 moles of CO2 and 1 mole of C6H12O6. All right, so we could either use this conversion factor or that one. In this case, we want to get rid of the C6H12O6, so we will want to use the conversion factor such as this, so it will accomplish that for us. Continuing on with our number from above, we're going to get 4.24528 moles of C6H12O6 using the stoichiometry from the balanced equation. 1 mole of it will give us 6 moles of hydrogen, not hydrogen, I'm sorry, 6 moles of CO2. I feel like I was doing an earlier problem there. Let's try that again. 6 moles of CO2 there. That's much better. There you go. That is going to cancel. And again, if you got a number at this point, we're going to multiply that guy by a 6. It looks like. Again, I'm not going to round too much here. 25.4717, I think. And that's going to be moles of CO2. And that would be our third step here. Do we need to go step number 4? We do, because we are looking for grams of CO2. Once again, we do need the molar mass, but we've got to remember at this point, we just did the stoichiometry. So we are at CO2. So we do need to go back to the periodic table and get the molar mass for CO2, which would be 12.01 grams per mole plus 2 times 16 there. For each of the oxygens, going to get us 44.01 grams per mole. We're going to use that as our final sort of conversion here. Step number 4, again, taking the number above here and continuing on, 4717 moles of CO2. Here, the moles are going to go on the bottom so that they cancel. Moles of CO2, 44.01 grams of CO2 up on top so that they do cancel. And we will end up with about 1,121 grams of CO2, or I guess if you want to do a little correct significant figure, I'm going to try to do it right this time, 1120 grams of CO2, and that would be based off of, we did have 3 this time, 3 sig figs there. Would take there, or you could do scientific notation if you wanted to, 1.12 times 10 to the 3, I believe. Yeah. Question on any of those steps? Again, you could hopefully see it is still the same 4 steps. Yeah. I find sometimes it's helpful for students to sort of do it step by step and get an answer. But again, you can kind of just squeeze it all into one big calculation if you want to do it that way as well and not get the answers in between. Any questions on that there? Starting to get the yes. All right, one last one here to prove that you got the hang of it here. All right, let's do one with a scary looking thing. Here we go. Oh, I know. I know. Don't be scared of it. Still the same 4 steps, no matter what's in the equation. All right. Grams per mole. And if we started with 0.7752 K2 PtCl4, also calculated the molar mass for you. So you do not need to go to the periodic table to do that. All right. Starting with this guy. How many grams of this guy are we going to end up with? Take a look since we're getting to the end here. So in this case, we do want to just continue like we've been doing. We want to balance the equation. So I do see some numbers there. And if you do check, you are balanced. So that's good. Next thing I want to do is convert whatever they gave me into moles. And I do need to do that. And by the way, there are a few extra numbers in this problem. So let's make sure we do use them correctly. As I box these guys out, these are the molar masses from the periodic table. So They were nice enough to give it to you. If they didn't, you would need to go to periodic table, use the formula like we did, and get those numbers. And by the way, as we talked about, just to make sure, you know, if you were going to calculate the molar mass of these guys yourself, you do want to make sure when you have something like this, you have one platinum you would look up, and you do need to distribute that 2 in for everybody. So you would look up on the periodic table for 2 nitrogens, 6 hydrogens, and also 2 chlorines. And if you do all that, it looks like this is the number that you get there. And same thing over here, you would look up, right, 2 potassiums, 1 platinum, and 4 chlorines, and that should give you this number here from the periodic table. So again, a lot of times it's not given to you. But even though the formula looks scary, you just got to make sure you get all the parts kind of like normal. So we do need to do that. And that means that really this is the important number here that we're starting with. We are starting with our 0.7752 grams of K2PtCl4. Once again, going to periodic table, are using their kindness here and the molar mass that they provided. We will use that as our conversion factor to convert it into moles. That would give us 415.1 grams on the bottom, a mole of this guy up on top in this case. Again, the grams will cancel out here. And if you got a number, which again, you don't need to do, you can just continue on with the calculation. But if you did get a number here, you would end up with something like 0.001867. Again, I'm not going to round too much here because we're going to continue on with the calculation as we do that. Any questions up to there? Step number 3 is really the stoichiometry step. So that is when we do go to the balance equation and we find that mole to mole relationship that we're interested in. And again, in this case, it's always going to be what you started with, which would be this guy. And it is what you are looking for, which would be that guy there. And this one is a nice relationship because it is how many moles of each? 1. Yeah. So from the equation, we see we get 1 mole of this guy. Gives us 1 mole of our product over here. If I could see what that says, 3 there, and a 2, Cl2. So we're going to use that, and our number that we started with there, we're going to continue on with it, 0.001867 moles of our K2PtCl4. Using the mole to mole relationship here, it is 1 mole of K2PtCl4 gives us 1 mole of our product here. 2 there. That's going to cancel those guys out. So I think I could still do the math here. That's going to be the same number. I hope 0.001867. But importantly here, we have now converted into our product, which is what we're looking for in this particular problem here. All right. I feel like I was missing something there. Cl2, right? There you go. Cl2. I feel like I was missing something. At this point, we're in moles of this, but we don't want moles, right? We do want grams. So we do need to do step number 4, which is the molar mass. And once again, if to you, you would go to the periodic table to get that number there. But since they did give it to us, we will use it. And that's going to be 0.001867 moles of this guy here. That's right underneath. Using the molar mass from the periodic table, we want grams up on top, 300.1 grams per mole. The moles will cancel, and that will get us here times 300.1, 0.5604 grams of P2Cl2 as well. Question on any of those steps? Even in this sort of scary looking one with scary formulas, it is still the same 4 steps, and you just follow them. Here, again, we have 4 sig figs based off of really the number that's up on top. And once again, like I said before, you could do it all in just one calculation if you wanted to. Question on stoichiometry or how to approach them. I would approach them with the same 4 steps that we've been talking about. It's a good way. Yeah. So in a lot of cases, a lot of problems that you'll come across, you won't have the extra numbers. That was just to help you so you didn't have to go to the periodic table. But in most cases and most problems you probably will come across, you probably just have one number to start with. So that's always a good place to start with in most problems. Other questions on that? All right, we're laid up there for today.